Started? Okay, cool. Hi, welcome. Welcome to the last day of TechEd. Thank you for joining me. My name is Vijay. I'm a program manager in the Hyper-V Replica team. And today, welcome to the presentation on Hyper-V Replica. We'll talk about performance, networking, and some of the other deeper details around Hyper-V Replica today. You must have seen this picture on Tuesday when Abhishek was presenting this. And Abhishek asked me this question: when you see this picture, what reminds you? What tells you? What's the top story that comes to your mind? Anyone in the audience? Okay, I can't hear them. Okay, so what reminds me is a very silly story, actually. A few years ago, we were driving from Niagara Falls to New York City, and on the way, we kind of took a wrong turn. We were kind of lost, and it took us about 2 hours to find our way back. And on the way, we actually couldn't find a gas station where we can fuel our car. And also, I was very hungry, and we want to have our dinner. But then we went to this Subway sandwich place where they make these Subway sandwiches. And we asked him, hey, can you make us a sandwich? We were very hungry. And he said, sir, my computer is down. I can't make you a sandwich. I thought that was the most bizarre story that I've ever heard. Okay, for me, it's okay. I can go to another shop and buy my sandwich. But imagine for the customer or the shopkeeper. Okay, this was a very small incident. But imagine that you had the outage for any reason. It could be your computer is down, your power is down, it's because of flooding, if it's the Hurricane Sandy that happens to you, that happened in a few months ago in New York, or it could be a fire accident, right? And if you have outage for many hours or many days, it's really going to cost you. It's going to cost you in terms of keeping the customers versus not having them, or you're going to lose customers if you have a disaster. Many customers here in the audience, this is probably very obvious, right? I want to have a good DR plan. I really want to have that. But oftentimes, the problem is it's very expensive. It's usually cost and complexity that deters people from deploying a DR solution. Okay? And the cost and complexity comes in like 3 forms. It's usually people, processes, and technology. Okay? And we really can't help you with the people and processes part, but definitely with terms of technology, we're going to see for the next hour what does Windows Server have to offer in terms of affordable technology choices to enable DR for your environment. We started this journey in last TechEd. I don't know how many of you attended my session. We started Hyper-V Replica in Windows Server 2012. We had a lot of success stories. Customers had very good things to say. It was easy, affordable, I could save a lot of money. And in fact, the last customer here, WorkID Safe, in fact, survived Hurricane Sandy. They failed over their workloads from their data center in New York to upstate and saved a bunch of their workloads from going off on the wayside. So they could get the business up and running in just a few hours without having any downtime for the customers, for their customers, actually. And in 2012 R2, we heard very clearly that we need to make investments in having a great management solution on top of Hyper-V Replica. So in Server 2012 R2, we actually made investments in twofold. One, we made investments to make Hyper-V Recovery Manager a cloud-scale management solution. And also, we made investments in Windows Server 2012 R2 to enhance Hyper-V Replica. Okay? Before we get into what Hyper-V Replica is, I want to spend a few minutes talking about what Hyper-V Recovery Manager is. Okay? So Hyper-V Recovery Manager, how many of you attended the session on Tuesday, Abhishek? Okay, just a few folks. Okay, so let me take a moment to explain what it is. Hyper-V Recovery Manager, it's actually still in preview. It's a Windows Azure-based service that enables you to manage, configure, manage, and do disaster recovery across sites. Okay? Because it's sitting in Azure, it can actually manage a single site, it can manage 2 sites, or even 3 sites or more, right? But remember, the Azure service is just the management head. But all the data replication is actually happening through Hyper-V Replica from site to site. Okay? And the question is, when should I use Hyper-V Recovery Manager, right? It's an add-on on top of Hyper-V Replica, which ships in Azure. It's very interesting to use, to think about Hyper-V Recovery Manager in the case when you have a large deployment. So with Hyper-V Replica, if you have a small deployment, you have a few servers and a few virtual machines, you can deploy that very easily using the Hyper-V Manager and the Cluster Failover Manager. But imagine you have hundreds of hosts, and you want to manage them with a consistent policy, right? And that's clearly when the Hyper-V Recovery Manager comes into picture. It allows you to manage your DR using SLAs. You can say what kind of RPO thresholds that my workloads can tolerate, and apply that policy consistently across all your virtual machines. And last but not least, it allows you to set up great recovery plans which allow you to do ordered recovery of virtual machines in a DR situation. So this session, I'm not going to drill down further into what Hyper-V Recovery Manager is, but there is a session that happened on Tuesday. If you've not seen it, you can actually go back to the videos and watch that offline. So for this session, we're going to focus on the fundamental replication technology that allows you to do the DR, and just focus on that part. So before I jump into this, how many of you are already deployed Hyper-V Replica in your environments? Okay, a few hands. How many of you still think it's you're a beginner, you still want to learn some basics around Hyper-V Replica? Okay, a few hands. Okay, so I think we have a good mix. So for those who are not familiar with what Replica is, it's an inbox replication product. It shipped with Windows Server 2012, and we've also made enhancements in R2 to improve the replication performance. Inbox replication, it's asynchronous, and it does replication at a VM level. Okay, it has all the primitives that you need to do a DR setup. So things like test failover, unplanned failover, planned failover, all these concepts are built into the Windows Server platform to enable DR. The third concept is around application agnostic behavior. So as long as you can virtualize your workloads and put them in a VM, Hyper-V Replica can easily replicate those virtual machines across the site. It doesn't matter what's running inside the virtual machine as long as it can be virtualized. And the workload itself does not need to be aware that Hyper-V Replica is really present and replicating the workloads. The fourth important concept is the storage agnostic behavior. I call this out an important concept because you can actually have your 2 data centers or your 2 Hyper-V hosts attached to 2 different types of storage. So on primary, you could have invested in SAN, using SAN for your storage, but on the recovery, you don't have to have the same hardware. You can have a directed as storage, or you could use SMB, or you can do mix and match. You can pretty much have SAN to DAS, SMB to SMB, any kind of storage architecture. So net-net, what does Hyper-V Replica give you? First, it's very simple because you can do it using the Hyper-V Manager and using the failover cluster manager. You can set it up very easily. I'll show you in some of the demos. Second thing is it's affordable because you don't need to buy any specialized hardware or have any specialized software for your deployment. And it's very flexible because you can deploy it with any kind of storage architecture on both sides. And you can also have different kind of network deployments that enable you to replicate across 2 sites within the same organization or 2 sites that are across 2 different organizations. Let me switch to... So let me quickly give a summary of what are the improvements that we made in R2. Okay? The first improvement, how many of you attended the session with Ben Armstrong last Tuesday, was it? Okay, just a few. Okay, that's good. No worries. We'll cover this in detail. The first improvement that we did was, as you know, in Windows Server 2012, the replication frequency was fixed. The frequency was always happening at 5-minute intervals, right? And there was a reason for that, because we were trying to optimize across multiple VMs. How do you make sure that they don't get any starvation or any kind of contention in the network, right? But now we made performance improvements in R2 that enable you to replicate at 30-second frequency. Okay? That's one of the big improvements that we made. We also made improvements to enable you to extend your replication beyond one site. So you can actually replicate from A, the primary, to B, your secondary, to a C, which is a tertiary site. Okay? We'll go into details around what the scenarios are for that in a minute. The third important pillar is Linux, right? Across Windows Server, if you listen to many of the talks, Linux has been one of the focus areas for Windows Server, right? Want to make Linux the best and first class citizen in Windows Server. Okay? Along those lines, we've made investments to make sure that Linux is supported even in Hyper-V replica environment. So you can deploy a Linux VM. You can use the Hyper-V server role, the Hyper-V server, the free SKU, to deploy a replica solution and replicate them across sites. And in R2, we've taken that a step further and also enabled you to add application or file system consistent snapshots for your Linux VMs. The fourth important area is upgrade. Okay? So for those who are already deployed on Windows Server 2012, you'll really appreciate this. Because if I told you that if I have to upgrade from Windows Server 2012 to R2, I just need to rip and replace everything, I'm just going to be prepared for tomatoes on my face. Okay? So we want to avoid that. And that's exactly why we made investments in cross-version live migration, storage migration, and some of the technologies across Windows Server. But remember that it's not an easy job to do upgrade across sites, right? So if you have two sites, A and B, but you want to have an upgrade experience across two sites, it's not an easy job. But we've taken a shot at it, and I'll show you through demos how you can achieve upgrade in just a few steps. Okay? Let me move on to the deployment scenarios. Okay? This is very familiar to many people who know something about Hyper-V Replica. You have a primary site and a recovery site, and you have your virtual machines on primary. You want to protect them. You can replicate them to a recovery site. And for some people who do not know much about Replica, it's not restricted to one-way replication. You can actually have VMs in your secondary site which are needing protection, and you can replicate them back to primary. So you can have some kind of bidirectional replication going on. The second scenario, which I've heard from many customers here in Europe, is doing cross-site across two different organizations. Okay? So I'm a small customer, and I do not have a secondary site where I want to replicate my virtual machines. Okay? And if I can do a replication from my premise to another customer, or another service provider who's offering DR as a service, I can just enable replication across sites. And this is not new to R2, but this has been there even in Windows Server 2012. The new scenario that we've introduced in R2 is the ability to do A to B to C. Again, here there are a couple of ways you can think about this. So you have your primary site and your recovery site. We've heard from customers that usually my secondary site is not very geographically separated. It's maybe across the river or just across the metro. So that's the scenario where we want to allow you to replicate in 30 seconds frequency. Okay? And from there on, I want to replicate to a tertiary site, which is really geographically separated. Okay? It could be hundreds of miles apart. It could be my own data center, or it could be a service provider that's offering me DR as a service. This way, I actually get the extra level of reassurance for my DR scenario. So let me jump into the demo. Okay? So here I have three sites. I have a primary, I have a secondary, and a tertiary. And pretend that the tertiary is actually a service provider. And I have a bunch of VMs that I'm replicating. So let me pick one of the virtual machines that is not enabled for replication. So I choose the server that I want to replicate to. In this case, I pick the secondary. And here I have the option of choosing whether I want Kerberos authentication or certificate-based authentication. So since my primary and secondary are within the same organization, I can just use Kerberos authentication. Click Next. I can choose what replication frequency I want. In this case, I'll choose 30 seconds. And I can choose if I want to have additional recovery points on my replica. And then I have choices around what the initial replication mode is. So I click Finish. And I have a replication set up at a per VM level from A to B. Okay? As soon as the virtual machine comes up on the secondary, I can go to the secondary. And there is my VM. And I can simply go, use the same experience that I did to set up A to B. I can extend replication to a tertiary site. And this time, I'm going to give my tertiary machine. So if this is my, if my tertiary site is actually a service provider, I could use a different kind of authentication. So from my A to B, I use Kerberos authentication because it's within my same organization. But from B to C, I want to use cross-site, so I don't have the trust relationship. I can set up replication with certificates. So let me select the certificate that I set up. Okay, I'll use that. And this time, I want to replicate at a lower frequency because it's going over WAN, and I don't want to bombard my network. I can choose whether I want to keep recovery points on my tertiary or not. And I can do Finish. Okay? So there you have it. And if you just see this is a tool that our test team actually put together, which kind of shows you how replication is going on. You have multiple VMs, and you have the replication going on at 30-second frequency from A to B. And then it also shows me the latency between A to C that allows me to replicate at 15-minute frequency. Okay, let me switch back to my. Okay, so one of the concepts that we took, very conscious decisions we took, was to make sure that all the three sites, the A, B, and C, can actually be managed individually. So thereby, we give the flexibility to set up your virtual machines any which way you want. So if you want to enable QoS on your site C because your virtual machines are running in a service provider environment, I can set up QoS. But if I don't have QoS or I don't need QoS set up on my A or B, I can do that also. So let me show that a little later when we do the failover demo. Okay? So in terms of failover, for those who are familiar with Hyper Replica, we support 3 modes of failover. We have test failover, which allows you to do your testing of your workloads. And this can be done without having any downtime to your primary workloads. So while the primary workload is still running, you can take your virtual machines, make a clone of it on your recovery site, bring up your virtual machines, do your testing, and when you're done, we clean up the whole thing. The second mode of failover is planned failover. In planned failover, you shut down your virtual machines, your primary, and then you send the delta to your replica and bring up your VMs on the secondary. And this one you use when you want to do a disaster avoidance scenario. So you know the hurricane or something is coming up in just a few hours. You can actually take a call and you want to make your move to a different site. You can actually use the planned failover to move your workloads from A to B. Right? And that way, you actually have no data loss. So all your data that you had on A is actually captured and sent to your secondary site B. The last but not least is the unplanned failover. So you've hit by a disaster, you didn't anticipate that, but you have set up replication, you can simply go to your replica site and bring up your virtual machines. But remember, with unplanned failover, you have the situation where your data, there's going to be data loss, right? And it really depends on what frequency of replication you've set. So if I've set 30-second replication frequency, then the amount of data loss is going to be somewhere between 30 seconds to a few seconds up or down because of the network latency. But if you set up something like 15-minute frequency, that's the amount of data loss that you're going to have on your replica site if you have an unplanned failover. So let me switch to a demo again, just to show you how failover works. Okay. So I have a Linux VM that I have set up and running. And if I want to do my testing, I can simply go to my Replica site and right-click, do a test failover. And here, in Windows Server 2012 R2, we have the ability to actually do a failover to a app consistent point. What app consistent is basically, because we don't have a VSS provider in Linux, what we do is do a file system consistent snapshots. So when we trigger a app consistent snapshot on primary, what we do is freeze the IOs on the primary Linux VM, capture all the changes, replicate them to the replica, and create a recovery point on the replica site. So you can pick a point in time which is either crash consistent or file system consistent. So let me pick the file system consistent point here, and I can just do a test failover. What this will do is create a new virtual machine called Linux VM-test, and it'll start it up. And you can put that virtual machine in a different network. Let me go ahead and start the virtual machine here. And while the VM is coming up, let me just show you a few properties that may be interesting to you. So on the recovery VM, you can see that I can connect the virtual machine to a network. And if I want the VM to be connected to a different subnet or different network, I can go ahead and choose a different network. Here I have just one virtual switch set up. If I want to specify what IP address the VM should come up with, I can give a different IP address. So really you can have A connected to a different subnet, B to a different subnet, and C to yet another subnet. Okay? And I was also talking about QoS policies. So if I go to the VM on the replica, and if I want to set up my storage QoS, I can actually change the storage QoS on the replica without affecting my primary. So if imagine you have a service provider, you're replicating from your premise to a service provider. Service provider cares about giving SLAs around QoS, so he can limit how much storage bandwidth you're using on the replica side. Then the customer can service provider can set up the storage QoS policies for the VM when it's running in the service provider's environment without affecting what it would be on the primary side. Okay. Let me, the VM has started, and I can just connect to it. Okay. And there you go. So it takes a bit of time to come up, and let me just kind of move on to the next part of the demo. So all that you've seen so far is using the Hyper-V manager, right? So you can use the Hyper-V manager to do your setup, your failover, and everything is good and fine and good. But imagine if I have to do this for multiple VMs, right? In a disaster situation, I'm usually not failing over just a single VM. I have multiple VMs to fail over, and I want to do them in an orderly fashion. Okay? So with Hyper-V Recovery Manager, which I talked to you earlier with the Azure service, you can actually orchestrate all of this using a recovery plan. Okay? But remember, Recovery Manager is useful in scenarios where you have a large number of VMs. You have a large scale setup, you have lots of hosts that you want to deploy. But if you want something much smaller in scale, you want to do a failover of maybe 3 VMs or 4 VMs in a unit or in a certain orderly fashion, you can do that using PowerShell. So with PowerShell, you have the ability to bring up your virtual machines in any order you want. And here I have a demo that I'll just show you that illustrates the same thing. Okay. So my colleague in Redmond, he actually put together this demo. It's based on SCO and Service Manager. So he's built a whole workflow that enables you to do a failover starting from Service Manager, kicking off a SCO workflow, doing the failover in orderly fashion for multiple VMs, and bringing them up in a different site. Let me just kick this off. It'll take a while for this to run. So I can go to the Service Manager console, bring up the workflow, and I can request that I want to do a failover to my recovery site. And when I do that, what essentially happens is it kicks off a SCO workflow. in the SCO workflow, I can define what VMs I want to replicate from one site to the other, and in what order I want to replicate these virtual machines. Okay? So I can go ahead and say I want to request a failover for my virtual machines. It should come up in a second. Okay? I can go request, and I say where I want to failover my VMs. I say next, and then submit the request. So this experience essentially allows you, like as a service provider, if you want to deploy your Replica environment and want to give a self-service experience for your customers to do the failover, you can use this tool that my colleague in Redmond built, Charles, and allows you to trigger a failover using Service Manager, and in the back end, it actually uses the SCO workflows to create these complex workflows to do the failover. So in a minute, it should finish. It takes about 5 minutes to finish. So let me just move on. So if you want more information about the demo on the SCO, you can actually check out that link over there that allows you to do a scripted failover. Let me switch. Okay. So failover considerations. As I talked to you earlier, we were discussing about how you can set up your workloads in different sites and how you can enable your workloads to connect to different subnets. So if you have your workloads that are server workloads, the chances are that you're going to have different subnets on your primary and replica site. So you need the ability to specify what subnet your virtual machines should be connected to. So as I demoed it earlier, you can see that you can set up your virtual machine such that you can connect to a different IP address. Or if you have a VDI workload, which just needs to come up and it has a DHCP server associated with that, it can automatically renew your IP addresses from on the replica site. The third option is to have network virtualization. With Hyper-V Recovery Manager, the Azure-based service, you can actually define how you want your networks to be set up on primary and secondary. And it uses the VMM logical networks to specify where your VM should be connected on primary and where your VMs should be connected on replica. That way, when the failover happens, it automatically connects to the right logical network on the replica site. But remember, this is possible only through the recovery manager. The fourth step that you need to do is update your DNS records. So if you have your virtual machines having a different IP address, your clients now need a way to connect to the VMs, and you can update the DNS records as part of the recovery plans. Talking about split brain scenarios. So one of the common disaster recovery scenarios is power outage. And what happens after power outage? You bring up your virtual machines, you're happy and running, but suddenly the power comes back up, and your virtual machines on your primary, very likely that they're going to come up automatically because you've set up auto start for all your virtual machines. But then you have a situation where you have your primary VMs that are running and taking requests, and you have your replica VMs also doing production workloads and taking requests. Now you have a situation where there are data on both sides, and how are you going to reconcile that? That's really what I mean by split brain scenario. Okay, how do you avoid that, and what does Hyper-V Replica provide in that context? The first thing it does is when the primary VM comes up on the primary side, the replication automatically contacts the replica site to see if it's running, the VM is running on the replica. And if it is, we automatically pause the VM on the primary. And this is a way that it helps you to mitigate this problem, right? So that way you don't have any data that's going into the primary VM when it comes up. A better solution, which is not directly available in the platform, is you should be able to take the VPN, the connectivity pieces, and disable them. So if you have a VPN connecting from your client to your server in the primary data center, the best strategy is to disable the VPN going from primary to the client. What happens after failover? We talked about bringing up in the right network, handling split brain scenarios. What about failback? This is something that we've been supporting since Server 2012. You have the option of doing reverse replication from your replica to your primary. And depending on the type of outage that you had, like if you had a planned outage, reverse replication is very simple. It just does a sync of what the delta changes are on the replica back to the primary. But if you had an outage where the primary was completely down, you've lost all your virtual machines and your VHDs, then you have to do a full sync from your replica to primary. Okay? A new option that we talked about earlier was ability to have replication from A to B to C. Okay? And you can use this as a way to mitigate your situation about, so if you want to continue protection, let's say from B to C after a failover on A, you can do that. So let me just show you that. So I have the VM on primary, and let's say it just conked off, and let me just turn it off. And now I can go to my VM on the replica side. Oops, sorry. Okay, there you go. So I have the VM on the replica side, and I can just go ahead, do a failover. When the VM comes up, now I have the option of saying whether I want to do reverse replication back to A, or if I want to continue my replication to my tertiary site, I can simply choose resume extended replication. What this does is takes the server B, promotes that to a primary, and starts replicating from B to C. So now A is disconnected, but you can continue your replication from B to C. So after your failover, you can go replication from B to A or B to C. Okay. So let me switch back. Capacity planning. Okay. You've seen all the features. You've heard about it. The next question that comes up to people is, how do I size my workloads? What do I do? How do I measure how much capacity I need in terms of storage or network for my deployment? So these are all the questions that keep coming to a customer when they're trying to deploy Replica. And if you had asked me this question like a year ago, I would have said the answer is it depends. Okay? And how many of you in the audience can actually estimate how much churn there's happening in your workloads? Any show of hands? Okay. Thank you and congratulate you for that. Because it's a very tough question to answer. Because if I asked you how much network, if you ask me how much network do I need, I'm going to tell you it depends on the churn in your workload. Right? And it's a very hard thing to go and estimate how much churn you have in your workload. And that's precisely why we built the Capacity Planner tool. And let me show you a demo of that. So here I have, one second. Okay. So here I have a standalone tool which enables you to plan your workload sizing. This is a standalone tool, so I can just bring it up on any machine and then point to the server where I want to collect data. Specify how much network bandwidth I have estimated, and I also say how long I want to run this tool. Okay. I say next. And I specify where I want to create my VMs. Let me just explain. Okay. Okay. So next. Okay. So what this tool does is basically kicks off a workflow. It does go to each of the servers that I'm configured as my primary servers. If it's a cluster, I go to each server in my cluster and look at all the workloads or the VMs that I want to enable for replication. And it does a data collection exercise. In that exercise, it estimates how much churn the workload is, what the churn of the workload is. And we recommend that you run this tool for your business day. Once you're done with that, we know exactly how much each workload is generating data. Once you have that information, it's very easy to estimate how much network that you need to replicate all these workloads from site A to site B. That's the first thing it does. The second thing that the tool does is does an initial replication and actually does a true estimate of what the real size of the network is. I gave an estimated size of network as 10 Mbps, but the effective throughput may not be 10 Mbps. If I had network latency or if I have packet loss, the effective throughput may be less than 10 Mbps. Okay? So we want to get a clear picture of what the actual network throughput is, and that's why this tool is very useful. So it finds out what the workloads are doing, finds out what the network is capable of, and actually generates a report at the end of the exercise. And this is how the report looks like, because this is going to run for like about 60 minutes. I set it up for 60 minutes. This is the report it generates. And this report may look very overwhelming, but it's actually quite simple. There are just a few things that you really need to care about. So if you ask me, is there a CPU impact and memory impact? With Hyper-V Replica, the impact on CPU and memory are very, very minimal. But what you do need to care about is the storage and the network. Okay? So let me show you what you should think about when you deploy Replica. These are the screen captures. So these are the key attributes that you care about when you're deploying your replication environment. The first thing is the storage on the primary side. Okay? The storage is really linear to what your VM is generating. So because we got an accurate picture of what your virtual machine is doing, we can actually tell you what the additional storage that we need on the primary for your logs. We also know how much IOPS that you need for all your workloads. So with this information, you can actually say, you can do a what-if analysis. So if I have VMs that are taking a lot of bandwidth, I can just skip them and say, if I reduce the workload, can I accommodate my replication across the bandwidth, across the network? The second most important area is the storage and IOPS on the replica side. Okay? And this is one area we actually made significant improvements in R2. Okay? Earlier, we were actually basing our recovery points using snapshots. So every time we actually get a recovery point on the replica side, we create a diff disk, and once you're done with that, we actually clean up the diff disk and merge that back to your primary disk. Whereas in R2, what we're doing is we're keeping track of all the recovery points using a undo log. Undo log is nothing but a copy on write. So as the change is happening and they are replicated from primary to replica, they are written to the base disk, the base VHD disk, and any changes that we're making, we are copying it off to a log file and storing that separately. So why do you care about this? It comes up in two contexts. The first context is the storage. So because we are storing this as logs, the amount of data or the extra storage that you need is exactly proportional to how much the VM is generating. Okay? The second impact is on the IOPS. Okay? Because I can do if I have to manage these recovery points, I just have to prune these logs. I don't need to do any sort of disk merge or AVHD merges. So simply I can just prune these logs. Thereby, I can actually get a great benefit in terms of IOPS reduction. The third important characteristic or the attribute that you need to watch for is the network bandwidth. So like I said, it's linear to what the workload churn is. And in R2, it's pretty much the same because we've not really changed the log format, and we have made it compatible between R2 and Windows Server 2012. Talking about network, let me go a deeper look at what the network topology is. We know how much bandwidth we're going to use for your replication. Now, how do you shape your network? So there are two classic ways we can actually deploy Hyper-V Replica. And These are the two classic, I'm going to show you both. These are the two classic ways you can deploy your network. The first methodology is using your, making sure that your Hyper-V servers on your replica are publicly routable to the primary. The primary is the one that initiates the connections, and it needs to know where and how to locate your replica server. And if you're doing it cross-site, you need to have the replica servers routable and available to the primary. You can deploy the replica servers behind a NAT, and you just publish a single IP address of the NAT back to your primary. So that way, the primary uses that NAT's IP address, connect to the NAT server, and the NAT will do the appropriate routing and go and find the VM where it is located on the replica site. Okay? And this is all possible because we have a component called broker that's sitting in the Hyper-V cluster, and it keeps track of where the virtual machines are in the replica site. So within a cluster, you have a broker. The broker, if a virtual machine moves within a cluster, broker knows exactly where the VM is. That way, that information is made available to the clients, and when the primary is trying to connect, it'll find the right host where the VM is located. That's the first method of deployment. The second method of deployment is using the site-to-site VPN. Okay? And this has some benefits. The benefits are clearly, because it's VPN, it's encrypted, and you have very secure connection. The other benefit in Windows Server 2012 R2, if you're a service provider, is the fact that you can have a multi-tenanted gateway on the replica side. That way, you can have a single VPN gateway allowing multiple customers, customer 1, customer 2, customer N, connecting through the same VPN gateway to my replica site. Okay? There is more content around the networking and how to actually configure the VPN gateways. You can actually attend the session on building hosted clouds, which talks in detail around how to configure your VPN gateways, how to set up your NAT and everything else around that. But I do want to call out another important detail in this picture, is the AD-VM. Okay? I have shown you like 2 ways you can deploy your AD in your environment. Okay? So typically, your workloads depend on some kind of authentication infrastructure. Typically, it's AD if it's a Windows environment. And you can deploy AD in 2 ways. One is you can use the AD replication to do your site-to-site and have that available on both sides. Or you can use Hyper-V Replica to take your virtual machine on primary, which is AD virtual machine, replicated to the replica site. Remember, on replica, it's always passive. So this AD is not functional until you bring it up in the event of a failover. Okay? Let me switch to network compression. Many folks ask this question. Is compression available in replica? The answer is yes. We do it on by default. And on top of that, customers do ask about, hey, can I deploy network dedupe? And the answer for that is currently we've been partnering with several vendors like Riverbed to enable you to do network dedupe. And we actually published a paper which talks about what kind of benefits you can get with Hyper-V Replica and Riverbed. And in order to do this, all you have to do is deploy the steelheads on both sides of your network, and you can get the compression or the deduplication across the 2 ends. And Hyper-V Replica just works out of box with the other network WAN optimizers. And the kind of benefits you get is, if you're doing initial replication, you get about 95 to 99% compression, which is very good across the wire. Network throttling, this is another common question that people ask. How do I throttle my network? I want to make sure that when I shape up my traffic, my replica traffic does not impact my other workloads, or if I have a management network or a network for doing backups, I don't want the replica traffic to bombard the other solutions in the deployment. Okay, let me show you a quick demo of how that works. Okay. So here I have 2 servers, and I have set up one VM for initial replication. Let me go ahead and start initial replication. And when I do that, if you observe the network, it starts to peak up, and okay, one second, it didn't work. Okay, I want to start initial replication immediately, and if I see the network, it starts to peak up. It goes up to like about 300 or 400 Mbps. But now if I want to restrict the network bandwidth, I can simply set up a network pause policy, and you can see that it'll bring down the network usage to about 12.5 Mbps. So thereby, you can actually enable network pause, control how much replica traffic is being used. And if I want to remove that, I can simply do the reverse and bring it back up. Okay, there you see. So it basically just shoots up the network utilization. So you can use the network pause capability in Windows Server 2012 to control how much network that you're utilizing for your replica traffic. Let me just switch back to the deck. Okay. So here are the commandlets that I just did in the demo that enable you to do pause. And the next topic I want to talk about is administration. So the topics are, how do I make sure that once the replication is set up, it's running in a healthy fashion? So here are some of the metrics that we track as part of replication. So first thing is, for replication, the most important metric is recovery point objective. What is recovery point objective? It is basically a measure of how much data loss you're going to have in the event of a failover. Remember, we're doing asynchronous replication from A to B. So depending on what replication frequency you've set, whether it's 30 seconds, 5 minutes, or 15 minutes, you're going to have that much amount of data loss. And the way we measure that the replication is healthy is using the metrics like the last synchronized time and the latency. Latency tells you when a change is made on primary, how long it actually takes for it to reach the replica site. So these information is actually available in Replica, and you can track this using the the Hyper-V manager or PowerShell commandlets. And if you're having a MOM pack, you can also deploy these as alerts. These alerts are available in MOM pack. And if the replication health goes from green to yellow to red, you'll actually get the right kind of alerts that tell you that replication is not healthy. Okay? The next thing I want to call out is if there is any kind of outage or the replication goes into some sort of failure, you get the same alerts. The replication state goes from healthy to a critical state. And if you use the Hyper-V manager, it obviously tells you what kind of failure you had. You can go to the event logs and do a deeper troubleshooting for your replica. Okay? What happens when there's an outage or kind of a network disconnect? Replication automatically retries in the event of a network disconnect. So if you had an outage for maybe 5 minutes, your network is a WAN connection, you have a drop of network, replication automatically resumes after the network is established, and it starts to replicate from where it left off. So if you've been doing an initial replication, it's like a 100 GB file that you're replicating, and if your network goes off, let's say at 70%, then when the network comes back up, it'll just start replicating from the 71st% and kind of resumes from there. And in the event that the two sites, the primary and replica, go out of sync for a long period of time, and the logs start to accumulate on the primary, right? And if that happens, and if the logs become very large, let's say over 50% of the VHD size, it is no longer very efficient to replicate those delta changes across the site. So that's kind of when we switch to doing a resync situation. So if your logs become very large or greater than 50% of the VHD size, we switch to something called resynchronization. And in resynchronization, we compute the checksum across the two VHDs and figure out what are the blocks that are different between the two and do the resynchronization. But remember that resynchronization can be an expensive operation, right, in itself, because it's going to do the checksum compute, so there is definitely impact on the CPU at that time. And also, it may take IOPS because it's going to do a deeper discovery of what are the delta blocks on the primary and replica side. So you can actually schedule the resync to off-peak hours, and we have the choices in the product to allow you to schedule it to off-peak hours or do it automatically immediately. Migration. That's another common admin task that takes place. So when you do storage migration, the question is, what happens to the replica itself? Okay? And in case of the common reasons you do migration of storage is because you're running out of disk space, or you want to migrate to a different or a better storage on your primary on the replica side. And when you have replication information, the logs and the undo logs automatically migrate with the virtual machine when you do the storage migration. The other kind of migration is VM migration. And you do this, again, for load balancing purposes, or you have to do some kind of server patching. You want to move your virtual machines. And if you're moving your virtual machines within a cluster, either on the primary side or on the replica side, it is very seamless. Okay? What I mean by seamless is the VM moves, and it can automatically detect where the VM is on the other side and start replicating. So there's no change that you need to do after a failover or after a migration on the primary and replica. But if you do migration across clusters or across two standalone hosts, you need to make sure that after you bring up your virtual machine on the new Hyper-V host, you know how to connect to the other side. You have to make those changes on the respective servers. Other VM lifecycle operation, online resize. This is a new feature that is added in R2, which allows you to do a resize of your virtual machines on primary. And if you do that, there is no impact on the replica until you start using the updated blocks. So if you've expanded your VHT, there's no problem. The moment you expand your VHT and start to expand the volume inside the guest, you need to make that change on the replica side also. It's not automated, so you have to go and do that change. You want to give the kind of control for each administrator. So if I'm administrator A on my primary side, but B is actually a hoster, you want to give granular control on how they do the resizing. So we allow you to do the resize on primary, and then you need to kick off a workflow to do the resize on the replica side. Other VM lifecycle operation is application patching. Application patching, what I mean is what happens if a VM is updated with a patch. Since we are making changes to the VHT, those patches also get automatically replicated. There's no action needed to be taken. So if you're updating the service pack, upgrading your OS, or if you're updating any integration components for your VMs, all those changes are automatically replicated. There's nothing that you need to do. Backup. This is another critical topic for customers. What should I do with backup, and how does it work with Hyper-V Replica? You should still continue to do backup, because some people get confused saying, hey, I have Replica, so do I need backup? And the answer is no. You still do backup on your primary, and that way you can get application consistent snapshots on primary. You can do backup on Replica also, but there is no difference or additional advantage of doing it on the Replica side. Okay. Let me move to seamless upgrade, and let me just talk about how this works. So earlier I talked about how we enable you to do upgrade from Windows Server 2012 to R2 using cross-version live migration. Okay? And I also talked to you about why it's such an interesting problem when you think about Replica. So you have two sites, and you have VMs on both sides, and you're trying to migrate them from one version to another version, and what is the impact on replication itself? So let me start with this picture, right? You have a primary site, and you have virtual machines running and connected to your replica. Both are, let's say, on Windows Server 2012. The first step you do is you set up your Windows Server 2012 R2 environment, your primary and replica. This could be another standalone machine, or it could be another cluster. The first thing is you do migrate your replica virtual machines from primary to replica. Once that is done, the replication automatically knows where to connect to. So if you go and replicate your virtual machines, you've been replicating from A to B, which is Windows Server 2012. After the migration of the Replica VM, the application simply continues from your primary server 2012 to your R2 environment. You can actually do cross-version replication in this environment. And when you're ready and you're ready to upgrade your primary site also, all you do is simply migrate your VMs from primary to your primary R2 environment, and replication automatically switches from the new server to the new Replica server. Let me just show this in a demo. So here I have the environment. As you can see, what I've done is I've showed you 3 sites. I have a primary and a secondary, and I have 2 Hyper-V hosts in each. I have a primary DC 2012 and primary DC R2, secondary DC 2012 and secondary DC R2. I have set up a virtual machine that is replicating from 2012 to 2012, and then when I was ready, I shut down my VMs or brought down my 2012 environment and moved my virtual machines to R2 machine. Now here I have a VM called Upgrade Demo 2. And if you see the replication properties, it is actually replicating from a Windows Server 2012 primary to a Windows Server 2012 replica. This is the primary VM, and you can see if you go to the bottom, it's actually replicating from my primary, which is Windows Server 2012, and my replica is a Windows Server 2012 R2. Next thing I do is when I'm ready to move my primary workloads to the new machine, I can simply go here, do a move of my primary VM. I choose where I want to move my VMs to. Sorry. Give the okay. I choose which folder I need to move my VMs. And if I click Finish, and just in a minute, what you'll see is my primary VM, which is running on Windows Server 2012, will automatically move to R2 machine. And once the migration is completed, you'll also notice that the replication automatically switched over and started replicating to the R2 server. So if I go to my R2 primary, if I go here, there you go. So you have the VM now started, and if you see the replication properties, it is already switched to primary, which is on R2, and replica is also on R2. Okay, so let me switch back. Okay. So I'm going to wrap up the presentation very quickly. So the next important thing I want to call out is positioning, right? Many people ask the question about what is Replica and how does it work with other technologies. I'm not going to go through the slide in detail, but as you can see, there is a place for SAN replication. So if you're actually using your workloads and they're very critical, you don't have any data loss tolerance, you want your RPO to be 0, you're still thinking about using SAN replication, and you should. But if you have workloads that are okay and having tolerance of anywhere from a minute to 15 minutes of data loss tolerance, you can look at Hyper-V Replica. As I pointed out, Replica works with live migration, storage migration. Guest clustering is one of the technologies that we don't support today. but that's something that we've heard a lot of feedback from customers. A backup, as I told you, that you should still be doing backups, and you can do backup on primary on Replica or on Replica, but primary is where we recommend because that's where you get the app consistent snapshots. And I also talked about System Center and how it works with that. And with the new introduction of Hyper-V Recovery Manager, you can actually manage this entire environment using System Center and Hyper-V Recovery Manager for your scale deployment. And with that, I just want to thank you for coming. And do test Hyper-V Replica and R2. There are hands-on labs that you can go and check out. And you can also do a preview of the Recovery Manager. If you go to the session from Abhishek, he'll tell you how to sign up for this session, and happy deployment. Do fill out your surveys. Tell us what you think about the session, and thank you.